Swayam Prabha. Digital India. Educated India.
Okay, so you do this instruments, and then we also can develop software to plan the surgery in 3 dimensions. It is now possible to take a CT scan of the patient's leg, convert the CT scans into a 3D model, use a 3D model to plan the cuts, exactly where you will cut and so on, transfer that information onto maybe an application, or take a printouts, or make a 3D model of the joint or the cut part and all that, and give to surgeons so they will implement exactly what was planned on the computer. It further increases the probability of more accurate surgeries. Okay. So finally what we did was to put together a host of technologies. We use CAD, we use simulation, both kinematic simulation, dynamic simulation, stress simulation. Okay. We use manufacturing simulation. At some point we used casting process to make the joints, but then we found the casting was not very reliable. We switched to machining process. There also machining path simulation, and eventually after all the things are done, the inspection using a 3D scanning and comparing 3D scanned object or component with the original CAD model. So you can use a lot of these technologies to make sure that you can get the things right. Okay. And of course we get newspaper coverage very nicely. This is just one of the many coverages which says that it holds out hope. Okay. And you will see that a lot of papers do cover technologies developed in IITs and IAC, saying that some new innovation is there, it hopes to change the future and things like that, but then you very rarely say that it's actually changed the life of someone. So we didn't want to stop here. Okay, we want to go beyond and say that let's go beyond hope and let's show that it actually can change the life of people. So fortunately for us, Dr. Chidambaram's office, who had funded the phase 1 of the project, they came back and said that why didn't you guys actually go ahead and put the joint in human body, patient's body, and not just do a theoretical R&D project for that. And they release in fact a larger amount of grant to do what is called as the clinical studies or clinical trials. Clinical trials means you are actually going to put in human bodies. Now that sounds easier than done, because there are a lot of checks and balances before you actually go into human clinical trials. You need to do what's called as a complete study protocol. How exactly are you going to do that? You have to put what's called as the inclusion and exclusion criteria. What kind of patients are you going to recruit? What kind of patients you will not recruit? Okay, which hospitals will do that? Which doctors will do that? What is the exact procedure for doing that? What will you do if something goes wrong? What about insurance for the patients? Okay, training manuals. And then we actually manufactured first lot, second lot, actual lots to put into that. This is the actual photograph of the surgical team getting prepared in the hospital. By this time Dr. Manish Agarwal had shifted to Hinduja Hospital, and so we had to take permissions from the Government of India. It's called DCGI, Drugs Controller General of India, and you also need to take permission from the what's called as the ethical institutional committees of the hospitals itself. And that's the actual 27th April early this year. The first surgery using the Indonesian knee joint happened in the hospital. You see Dr. Manish Agarwal here. That's the team which you see in the photograph, is the team from the NFTC Hyderabad. They came down because they were so excited after so many years, all the manufacturing, finally it is going to be going into someone's human body. Okay, and then post-op surgery, which you can see, the entire, there's no femur, there's no tibia, part of the tibia. It's all replaced by the artificial processes, right? Can you imagine how many days after surgery? Second day after surgery. Okay, the patient is actually walking on his own feet without any crutches. Can you make out which leg? Because you saw L in the picture, in the X-ray. Pretty natural, right? Okay, that's the first surgery which happened, and we were all thrilled. And then second surgery happened very quickly within a month of that. Again, you can see the entire processes assembled on the thing, and the tumor, big tumor again removed, and entire gap reconstructed with this knee joint. Again, you can see very clean lines. You can see very beautifully the going into the bone, perfectly centered, right? From outside, you cannot make any difference about the shape of the leg. And by the way, the natural, some of the muscles are retained. So the joint is inside, you preserve the muscles, you preserve the blood vessels and nerves. Nerves also, otherwise how are you going to operate the leg? And then you're going to put the whole thing back and seal the whole thing. These are nothing but your sutures.
So what about the relation with the kneecap?
Kneecap is still there, and kneecap glides onto the patella. The kneecap is, this is kneecap for you, and it glides onto the patella just like a natural human knee joint. Some are lost because of tumor, because along with the tumor, some parts are taken off. So I won't say this leg is 100% as strong as the other leg, which is maybe good, but the loss may be as little as 10-15% of error, which is good enough. So this, you can see the patient now, again after 2 or 3 days after surgery, walking.
So what is the weight of the entire joint? Because I think earlier
Weight of the?
Weight of the joint.
About a kg, about 1 kg.
How is it compared to the actual?
It is little heavier than the human body. Maybe it's about, you can say twice, almost twice you can say. Yeah. But compared to the entire leg weight, the incremental weight of the leg is not more than maybe 5-10%. Our leg is pretty heavy. They can almost sit squat on the thing. If you remember, it's about 150 degrees. So just to compare with the imported knee joint, okay, imported knee joint does not have this much flexion. They say you have to sit only on chairs. Mostly it is 90 or 100 degrees, imported knee joints. This can go up to 150 degrees, number one. And we give this beautiful little bit of that movement, okay, because of which the stem will not take shear stress and break eventually. So this takes a little bit of, it's a little tight because it's not yet put on the machine. And these are the components which I can change. I can remove this component, put it directly onto that, I get a shorter one. But if tumor is large, I can put a larger one of this middle part and I can build up the whole thing. Then I can change this small, medium condyle can go with a small, it's called TBL tray and vice versa and so on. Mix and match I can do.
So what is the material for the?
So I mentioned to you, this is cobalt chromium, this is titanium, this is also titanium now, okay. This is also cobalt chromium. Now we're making out of titanium, this whole thing. And this is your ultra high molecular weight polyethylene. So you don't put metal to metal movement. Movement should never be metal to metal. It is moving on a polymer. And there's an axle here. And so axle is where our design innovation came. We are patenting that. And even axle is surrounded by a poly bush. So again, there is no touching or contact between metal to metal. And if there is no other adverse, usually they go by adverse patient's reporting. Patient says, I have pain is increased or something is happening. For example, the imported joints, there was no shaped poly like that. This whole thing can rotate freely. So patients are very uncomfortable standing on their feet. They would say, no, I want crutches, someone should hold me and all that. Because this naturally stops nicely. You saw the patient walking, this patient walked with a walker. The previous patient could walk without a crutch also. And that's the 3 culprits. Yeah, it happened because we 3 hung on for the whole, whatever, 15 years. Okay. So without these people, I would not have gone further. In fact, Dr. Bala on the left side, he's the one who is taking the actual punishment, actually taking the lead, manufacturing that and so on. So I only started that. We didn't give up. India, sometimes it's very easy to give up because there are always obstructions. I haven't told you about all the obstructions we had in the project. It'll take you 2 hours to talk about all of them. A lot of frustration, a lot of obstructions, a lot of times, but you never thought of giving it up. You always said, no, let's keep pushing, keep pushing, keep pushing.
Even now, 100 patients are going to be, operated. Only 2 are over across 5 hospitals across the country. There are 10 orthopedic surgeons who are going to come in, and they have been trained to do this. And and basically, then there will be the next stage. That will be the pilot, right? 100 will be a pilot, and then the next stage of large-scale implementations. Professor Ravi did mention about a very good thing which happened in all this is both the manufacturing, the NFTDC, and at Professor Ravi's lab is called the Betic Lab. Now, much more, large-scale innovations are happening, and Professor Ravi will come back again and talk about all the other large-scale innovations, how he is building entrepreneurs, how he is building, biomedical innovations, and how he, conducts the hackathons. All that, will come again in the next session.
So we cannot insert a screw from outside because there are chances of infection, and we cannot open up to place another module inside too,
Yes.
because that's also a very big process.
Yes.
So can we calculate the average knee movement per year for children and insert the lever in the knee movement So as per the knee movement per year, the
Good idea.
joint size
Good idea.
increases.
I know what you're saying. It's a good idea.
And now we have, since you showed the manufacturing in die molding machines in the beginning, so now we have die molding machines that can go up to the accuracy of 10 to the power minus 5 centimeter, sorry, millimeter. We saw it in last few classes.
So if you can come up with a mechanism which automatically grows
Yes.
with the movement is what you're talking about.
Yes. It
That's
can
a-
be paired with an application like Google Fit and all, which tells how many steps are remaining to increase by how much, which children can use to like grow.
Or you can tell them quota. The quota for this year is, 5 lakh steps.
Because every children hit puberty at different point, so
Okay.
that also.
You can always go a little more, a little less, depending on how much you are growing. I think it's a good idea. And sometimes growth happens in spurts. Growth is not always uniform. I've not heard about anyone thinking about something like that. I told you the two mechanisms which already exist in the market. Definitely worth thinking about. So chase it, and I'm there with you, right behind you. Do it. Yeah.
So further to Professor B. Ravi's presentation, let me show some very, interesting interventions from design. And all of you are, design students and you're doing applied ergonomics right now. So let me show you some parts of that from a real case study. So here, for example, what would a designer do in all this? So I was, of course, part of the team, always supporting and being there in the meetings and, during the building of the prototypes and for the suggestions and critics. But a very important aspect is, if you look at the total number of components, how would the doctor who is operating understand all the components? How would each component fit each other? What type of fixtures and what type of aids will I give him to understand how these things go into one another? Right? Because he's going to be a new doctor, right? An orthopedic surgeon will just get this prosthesis and he has to operate upon. He may do some training, he may do some manual. You can take this forward. So for example, we did talk about all the aspects. How many parts are there? Can you see all the parts? The femoral stem, the femoral collar, different stems, right? Different heights, because the cancer is at different levels. So you have different heights. So here you need a stem to attach this to this femoral stem. And this is a femoral extension. To attach this to this, we need an extension. And this extension also different sizes, depending upon what the conditions are. And then the most interesting part is the circlip. After assembling the circlips, which you've seen moving parts with a round spring-like grips. So these are the circlips which get attached, and these are the two bushes which go in. Ultra high molecular weight polyethylene. This is the very, very high-end engineering polymer which is specially designed because it's very human-friendly point of view. And this particular thing is again made of that because it's a rotating part. And then you have the central pin which is sitting in between. Remember it could move. So this central pin is oblong. Okay. And this is the lock to prevent it from moving, the ML lock that has to be inserted first. This is the tibial poly. It's a polymer between the two joints. Then we have the, aspects of the tibial tray in which this poly sits and the tibial stem. So now I want to tell you about the, next phase. What happens with so many parts? Is it too complex for the doctor? Is it very easy for the doctor? Is it too complex for the operation theatre? This is a mega operation. So what happens? You have tremendous amount of preparation. So the whole team prepares with the, inline. As soon as the doctor says you have to give that type of thing, on all of them are autoclaved and, sterilized. Different types of, instruments. Some instruments are common operating instruments, and some of them are instruments for fitting your prosthesis, and those are called ornamentarium. Ornamentarium is the name given to the tools which are used to fix the prosthesis, and that is given by whom? The ornamentarium is sent by whom? The manufacturer of the prosthesis. So he will send you the kit along with the tools, the prosthesis along with the tools. So this is the operation table happening, and these are what are the trays with all our ornamentarium. These are called dummies. Very interesting. Within the ornamentarium, you have dummy pieces to check. So there are dummies to put and check, and then you're opening the sterilized prosthesis component. This is a collar to open the test sterilize and then use it, because that's very expensive. So dummies can go to sterilization again. Okay, so look at the reamers and all the tools which you see over here. the drills, and you can't drill the bone at one go, right? You need to drill it slowly, and you need to drill it at the right dimension because the stem should go in and lock. Though you use something called the bone cement, the stem goes in. It's like carpentry and cementing. There's no difference. But here, most of the materials used for all these purposes are very advanced. So there's a bone cement, and you ream accurately, put the bone cement and put your stem. The stem integrates with the bone. This is all, the study I'm showing you is done by an MDes student of mine who joined me in the studio, worked with me for 1 year to support this whole processes development and taking it to the pilot production. We are going to 100 numbers, right? We have to train 5 doctors across 5 hospitals to get this work done. How will you tell them how to do the operation? Whereas Manish Agarwal, who is our doctor with us for the last 14 years, he knows it very well at the back of his hand. You just give him the process, he will quickly, assemble and put it. But for a new orthopedic surgeon, you need to tell everything about all the aspects. And how will you do that? So these painstakingly, Dattaramchari, our project associate, would sketch every component and every aspect and create a manual for the doctor. He talked about every part of the tool being used, how the tool is being used, how the ornamentarium is being used, how will you put, how will you mallet, how will you cement, what will be done when. He created the complete journey for the doctors till the stitching back. So this is how the whole process goes in, and this is the step-by-step process. So now we need to also design the box for our product, right? Because we are designing a new processes. So we have to design the ornamentarium box and the packaging for our product. So we studied what type of sizes we are getting, what type of components we are getting. These are the initial ideation sketches. Then the surgeons' insights were taken. Very clear, surgeons were very clear that, unless and until the basic things of the products like usability, packaging and handling are clearly defined and finalized, the product can be granted a medical approval. It can't be granted a medical approval till you have all these things clear. You're looking at a world processes. So how can it be implemented? What happens? What type of packaging we use becomes very, very critical in the whole journey. And doctors and surgeons will actually use the instruments in a non-case for understanding the basic look and feel and understanding the handling of the instruments. So for this, what we did? We bought a mannequin, cut the leg, made holes in the mannequin, and we got the doctors to operate on that mannequin. That's all this idea was from our designer, Dattaramchari. And the doctors were amused and they were very happy because they never did that before and they found it very easy to learn. And this whole workshop was done in NFTDC when they were all visiting them, and they all checked how things are happening, because here you can, play with the leg, you can cut the leg, you can, put all the things inside, and it was very open. And it looked, that's the beauty of design. See, we do the things which are the trials, the theatrical aspects, doing a mock-up study, and that we fed in, and then NFTDC was extremely happy that they could point out a lot of issues of, some pin not being, how will you adjust the clip from the back? It was very difficult. So can we have one side clip rather than both sides clip? All these suggestions were coming in after you actually did something called operation using dummies. So now looking at the preparation for the surgery. So when you have a theatre, operation theatre, it's a very complex phenomenon of people around you. There are anesthetists, there are multiple helps which the doctors have. There are senior doctors, there are junior doctors, there's the main operation surgery, and and there are these people whom the prosthesis manufacturer sends because they know their prosthesis well. So those people also inside the operation theatre. This is the first time we got to know that even the manufacturer sends his person there to stand there to get the things done. So we were just, we made all these components of see where all you'll keep what, the tools, the reamers, the trials, the dummy trials. And then here we are the ornamentarium tools, and those are how the doctors will be all around the patient to get the operation done. And there is this ornamentarium assistant. So these expert and this assistant come from the manufacturer. So what type of study did we do? We said we have to make this box very user-friendly, right? That's our job. As a designer, I want to make everything easy for the doctor. So very clearly, clear division about off-table and on-table tools. What is this off-table? Assemble some of the components there and give to the surgeon, and he would put inside the bone, and then he will have some tools to put the circlips, to put the clips inside, to put the sockets inside. All that will happen at them. So that is the on-table and that's the off-table. So he made a division so that's easy for the doctors and for the assistants to pick up. See how nicely it has been done. And then he packaged the product so that's easy to pick up. Look at the packaging. These are the clips which go and lock the pin which is being used. And there's 2 extra clips if the clip falls down. It has a special tool to hold this like this, open it, push it in and leave it. So because it's spring loaded, what happens is every chance that it may go away. So there's extra 2 given which are completely sterilized, which are available for the doctor. And designing of the clip holder and how it will work also is part of the armamentarium design. And we created the grips and what type of openness we need to have, what type of profiles we need to get, and all these things were done. And every part, the on-table and the off-table aspects, each tool was considered, taken, and a process was defined of what will happen. Remember, there was a picture board to show the process of operation. Now there's a picture board to show how each part is being worked upon, and that made it very, very easy and useful. And then again, the surgical hammer, what type of load comes, how heavy should you make the surgical hammer? Because you were tapping it once, it can damage the whole body bone, for example. So you need to really have very, very right type of weight for the right type of application, because you're sending the stems inside by actually hammering. He made this, aspects of viewing, locating and holding. You have to see and you have to pick up. Like for example, the sizes, you don't need to catch it. You just see the size because there's a large text over there, small, large, you can pick up. So this particular is the locating, that you take them and put them in the location. And then this is about actually handling him. So these are the 3 icons he developed to make it very clear that which of them you're not touching, which of them you're placing in the right location, which of them you're opening. See, it's a very big risk if you open three sizes unnecessarily. You lost the sterilization aspect, your repacking aspect is very, very expensive. Okay, so we talked about the tibial side, the femoral side. See, very clear, because there are 2 sides of the table, the bottom side and the top side, and then the common tools which are going to be used. And every component was considered, and what type of activity will happen was, taken care of. And that's how the whole, operation planning was done. So that's the whole journey of the design intervention of how I, as a part of the support team. So there's a core team, there's a support team. Like me, there were a lot of people in the support team. And then there was this larger enterprise-wide team. So the teaming was very interesting here. The first team consisted of the 3 professors who worked day and night, and their team members. They had at least 4 to 5 team members. Professor B. Ravi had at least 10 to 12 MTech students and 4 PhD students whose contribution was there in this. Research contribution. So we have a whole large team of support structures also behind all this, taking things forward. Okay, so this closes our understanding of how how we need to really work across domains, across disciplines, and without each other's strength and input, this product could have never come out. And the biggest credit is also to the Principal Scientific Advisor's Office, which is at the government level. It's the Prime Minister's, they directly report to the Prime Minister, the Principal Scientific Advisor's Office, and their office was constant support all these years. With the type of funding which came in was very, very large. Without the funding, this type of activity cannot have happened. So with that aspect now, we got, everything is first time. There was no process in the country. So first time the DGs, the controller gave approval for this. That was the first time. Because to doing first time, they took 8 or 7 meetings to get this cleared.